Hello friends, in this video we are going to discuss about the voltage control resistors that can be fabricated using the junction field effect transistors. Voltage control resistor is nothing but a resistor where the value of the resistance can be controlled by some amount of voltage. Now, for that, if we look at the drain characteristics of a p channel JFET, the drain characteristics looks like this, and the drain characteristics of the JFET, we are changing the value of VGS to different value, and this current ID SS is the saturated current during VGS equals to 0 volt. And when VGS has become a plus 1 volt, then let us name this saturated current as ID SAT 1. Similarly, for the VGS equals to 2 volt, the saturated current will decrease and it is ID SAT 2, and similarly it will be ID SAT 4. Now, the pinch-off voltage is defined for VGS equals to 0 volt, and this is the pinch-off voltage. Now, if the VGS is equals to the pinch-off voltage, let us assume that the pinch-off voltage of this p channel JFET is 5 volt. Now, if VGS is equals to 5 volt, then the ID current will be 0, so the characteristics will go near the x axis. So, this is for VGS equals to Vp, and we have assumed that Vp is equals to plus 5 volt. Now, as we know, there are two regions inside this drain characteristics. The first region is that it is the ohmic region, and the second one is the saturation region, where the drain current is saturated, and in the ohmic region the drain current is increasing linearly with the source to drain voltage. For different value of the gate to source voltage, it is taking different slope in the ohmic region. So we can say this slope of every graph, this slope and this slope, the slope is changing with respect to the gate voltage. That means we can write that in ohmic region the slope of the characteristics changes with respect to gate voltage, that is VGS, and slope changes means the resistance of the channel changes. That means depending on the value of the gate voltage, we are getting different channel resistance value. So we can say in a ohmic region a JFET can be used as a voltage control resistor, where the value of the channel resistance of that JFET is controlled by the gate voltage, and this gate voltage is the main factor that is controlling the channel resistance, and this channel resistance is also called as drain resistance, and it is denoted by small r suffix small d. This Rd has a equation of R0 1 minus VGS divided by Vp whole square. So this is the drain resistance equation where R0 is equals to the channel resistance or the drain resistance at VGS equals to 0 volt. That means from the drain characteristics we can define that this is the R0, because here VGS equals to 0 volt and the channel resistance and the slope that we will get, from that slope we will get the R0 value, and Rd is the resistance of the channel at some particular value of VGS. So this is the way by which we can use the junction field effect transistor as a voltage control resistor in its ohmic region. Now if we see the symbols of JFET that are used in the circuits, then we can draw that for n channel JFET the symbol looks like this. We know that JFET has 3 terminals. So this is the drain terminal, this is the source terminal which can be interchangeable, and this is the gate terminal. Since it is a n channel JFET, so we are using a arrow sign like this, and similarly for a p channel JFET the arrow sign will be in the outward direction like this. So this is the gate terminal, this is the drain terminal, this is the source terminal, and it is for p channel JFET. So these are the symbols of the JFET that will be used in the circuit notation, and this is all about the voltage control resistor and the symbols of the JFET. Thank you.